This one's fine. This one we need to fix. What's going on, everyone? Welcome to episode 5 of Everyday Python Projects, and today's project is to build a currency converter. This converter will return the value of your domestic currency into 32 different currency pairs. Now, I'm gonna be honest, that part only takes like 2 minutes, so if you're wondering what the rest of the video is, stay tuned. For the first part of this video, we need to import a library called forex-python converter. If you don't have this installed, just use pip in your command line or terminal to install it like so. So you see I already put it in here, but if I wanted to pip install forex.python, I have it installed already, which is why it says requirement already satisfied, but if you don't, it'll be installed right here. All right, now let's import this into our script. From forex_python.converter, import currency rates. We're going to create 3 variables, one for our base currency, one for the amount we want to convert, and one for the currency we want to convert to. Let's say base currency is going to be equal to an input with the prompt, what currency do you want to convert? And we're going to capitalize this. Next we'll have the amount, which will be a float, and another input, how much. And finally, second currency is an input. Okay, and what would you like to convert it to? And this will be capitalized as well. On a side note, this won't work if the currency isn't uppercase, so the upper method I'm using is crucial for this to function properly. Now we just need to use forex-python to get the conversion rate, and we could print it out to the console. So let's create a variable called rate, and we'll use currency rates dot get rate. We'll put in our base currency and our second currency, and then we'll print out the conversion rate multiplied by the amount that we want to convert. So let's test this out with USD and Euro. What currency do you want to convert? USD. And how much? Let's say 1500. Okay, and what would you like to convert it to? Euro. And we get 1235 spot 99 euros. Now we can double check this by going to Google, USD to Euro, and I put in 1500. And it comes up with 1236 spot 25. Now, the reason as to why there's a difference between Google, which is real time, and this library is that these rates are being pulled from the ECB. The ECB stands for the European Central Bank, and those rates are recorded once a day. So there might be some kind of lag between the current rate and the time at which that rate was recorded using this library. Now, that's pretty neat that we made this so quickly, but let's be frank, we could have done the same thing in Google in like 5 seconds. The real power behind this tool is how we can apply it to larger, more broad-based projects. The first thing that came to mind is how this can be integrated with e-commerce. So let's say you have a major store on Shopify and it sells products all around the world in different currencies. Unfortunately, your daily invoices are reported in the foreign currency, not in your domestic currency. So if the knife is what does the work for Gordon Ramsay, then Python is what does the work for me. To speed this up for you, I've already created a spreadsheet with 2000 rows of random product data like so. So here we have 2000 rows of data, our random currencies that we generated from that library, and then revenue, and these are just random numbers. If you're wondering how you can generate these random currencies so quickly, it's actually really easy. So here's some code that I wrote earlier, and we can comment all of this out. This should be cur list. Okay, so instead of calling the getRate method like before, we can now call getRates, which takes one rate as an input and returns its converted value across all major currency pairs. So if we were to run this, we would see that for the US dollar, these are all the different conversions across all major currency pairs. And it's a dictionary like so. Then we make an empty list called curList to store all of the currency codes. Now we just need to make a loop for however long we want it to run. In this case, I'll run it 10,000 times. And in each loop, we're going to randomly pick a code from what is available. This is why the random library is used right here. Now remember that the variable rates, like I said earlier, is a dictionary. And what we need to do is get the keys of these dictionary, since each of these keys are the currency pairs. Since a dictionary's keys aren't subscriptable, you have to convert it to a list first. Then we'll just append the randomly chosen currency code to our symbol list. And finally, we will use pandas to take the symbol list, turn it into a data frame, and then export it as a CSV. So if we were to run this, you can see the program is executed. And now I'll open it up. And here are our 10,000 randomly generated currency codes from our list available right here. Within a second, we were able to get this data. And this can scale pretty far for a normal computer. I mean, if I were to do this for 100,000 rows, that took less than a second. You could easily do this for a million or 10 million different rows. You can totally grab the list and turn it into a CSV using pure Python, but as you get more comfortable with Python, you'll find yourself dealing with larger and larger data sets. When that happens, and it will happen, it will, pandas will become your new best friend because it was created specifically for data analysis and manipulation. I'll make a video soon about some of my favorite methods with pandas so that anyone watching can get up to speed really quickly. Okay, so now that we have our product data, let's put this into memory and convert our foreign revenue into domestically valued revenue. So let's create sales data, which is pd.readExcel, and we're going to put the name of our spreadsheet. Here I just called it 5 currency converter data. And what this does is it's going to take our spreadsheet and put it into a data frame associated with the variable sales data. A great thing about pandas is that it has a ton of different ways to load up your data. That being said, for the everyday user, I recommend using pandas read CSV if you're dealing with larger data sets. To verify what I'm saying, I did a test where I read 10,000 rows of data using pandas read Excel and pandas read CSV. On average, over 100 trials, read CSV was 66 times faster. Then I did a test where I made a CSV with 10 million rows of data, and using pandas read CSV, it only took about 1.2 seconds to load the entire thing. So if we use our average of 66 seconds, we can estimate that it would take around 78 seconds if I had used pandas read Excel, which is a huge difference, and you can see right away these small time savings here and there start to add up really quickly. Now we're going to create a column called exchange rate USD. And the way we get the data requires a lambda function. So let's write sales data exchange rate USD. And this is going to be equal to sales data currency dot apply lambda x rates x. Okay, so what this means is we're going to take the data within sales data right here. So first, let's just read this into memory so you guys can see it. We're going to take these currency pairs, these currency codes, and we're going to apply it into rates. So from what we saw earlier, rates are each of these is this dictionary. Now, were I to say something like rates GBP, it will then pull that value. So here, we're basically taking this entire column of codes and using it with rates. So we can get all of the rates at once rather than writing some kind of loop to go through it step by step. A lambda function is called an anonymous function since you don't define its name the way you would with a normal Python function. They're super useful when you need to apply a function for a short period of time, or when you need to use a function once and then never again. It's a lot faster and cleaner syntactically than trying to write a normal function the pure Python way. Then we're going to value the foreign revenue in our domestic currency. In this case, I'm using US dollar, but any currency can be used for this. So let's write sales data USD revenue is equal to sales data, and we're going to take the revenue column and divide it by the exchange rate. You have to divide the revenue by the exchange rate because the exchange rate is what $1 would be in domestic currency. Okay, now let's execute this and let's check our data frame. And there you go. Now you have your revenue in your domestic currency. So we can see here, let's use the peso for example. We received 77 pesos for product 2. This is the exchange rate. So in US dollars, we received $3.80. Now, there really is no reason to stop here. There's loads of other stuff we can do now that we have this data stored in our data frame. Maybe we could find our total revenue. So let's write total sum and then print sales data USD revenue dot sum. Or we could find, the most profitable product. Let's write max. The max is equal to sales data USD revenue dot IDX max. This will find the location of the product that had the highest US dollar revenue. And then we can print that to the console, sales data dot loc the max. And here are a few other things that we could do. Maybe we could find the product that made the least amount of money. The 20 best products. And finally, we can save this information to a CSV. You can do this to an Excel file as well. Just change to CSV to Excel, and as well as the extension .csv to .xlsx. Okay, now we can run this. And we have all of our outputted information. Now let's just check to see if the CSV is here. And it looks like it is. We have our data frame here, all of the columns, and our US dollar revenue for the 2,000 different products. There you have it. You just got some practice using Python to wrangle with currency data, and you learned how it could be applied to a large-scale project. With a couple mods and tweaks here and there, you can run this at the end of every workday and have your reports automatically generated, whatever they may be, without ever having to touch a script. If you enjoyed the video, drop a like below and subscribe. That's it for today's episode of Everyday Python Projects, and I'll see you in the next one. Unfortunately, your daily invoices for whatever reason are reported in the foreign currency.